As we saw in a previous video, in order for a mobile robot to carry on navigation, it needs some types of information, and among them, the robot needs information about its own movement. And odometry is the main mechanism for that. Odometry means something like distance measurement. But although distance measurement might suggest linear distance, in fact, odometry measures both linear and rotational distance, although rotational is much more difficult. And we speak about distance measurement, but really odometry mechanisms do it computing. First, they estimate time, estimate speed, and then compute distance as velocity or speed times time. So we need to measure time and speed or velocity. The robot can get information about time very easily using its own internal clock, and the results are very precise. Not so easy in the case of speed. There are mainly three alternatives. The robot can compute velocity using the power of the engines, but the results are not very good. The robot can also use wheel encoders, which measure the movement of the wheels, the velocity or acceleration of the wheels. And maybe you remember them when we spoke about velocity or speed sensors. Finally, the robot can use inertial measurement units. Inertial measurement units combine accelerometers that measure linear speed and acceleration, and gyroscopes that do the same but with angular speed and acceleration. The disadvantage with odometry is that it employs indirect measures. It doesn't measure directly distance. And usually that gives rise to several errors because the relation between variables are not linear and tend to vary over time. So the robot needs something more, needs some help. And that help comes in the form of localization. Localization gives the robot its absolute position. So what the robot usually does is gets its absolute position and periodically updates it. And between that updates, it employs odometry to know the intermediate position. So we need to speak about localization, and we will do it in the next video.